Okay, so now we're going to look at surds. So surds is an irrational square root such as square root of 3 or square root of 5 or square root of 7 and so on and so forth. So for instance, square root of 4 is not it's not an irrational number because the square root of 4 is 2, or technically plus or minus 2. Okay, so when it comes to surds, there are a few rules you need to know. First of all, when you have square root a times by square root b, essentially you're doing the square root of a times by b. So let's do an example. Square root 2 times by square root of 3 is the same thing as saying 2 times 3, but all under the square root, which we get as square root 6. Similar thing when dividing. So if you have square root 8 divided by square root 2, it's the same thing as saying 8 divided by 2 all over square root. 8 divided by 2 is square root 4, and square root of 4 is 2. However, remember that if you have root a plus root b, you just keep it as it is. So for instance, if you have root 2 plus root 3, that is it simplified. You can't simplify it any further. Then if you have brackets a plus root b bracket squared, remember you have your double brackets, and then you would normally do the same method that you would do when expanding double brackets, your FOIL method or your multiplication table method. And once you expand it out, you would get an answer of a squared plus 2a root b plus b. Similar thing when you have brackets a plus root b in one bracket and then a minus root b in another bracket. When you expand your brackets out, you would get a squared plus root b minus a squared plus a root b minus a root b minus b. And these two, a positive a root b and minus a root b, will cancel out each other. So it will always simplify to a squared minus b. There is something that we need to know, which is something called rationalising surds. So when we rationalise surds, that essentially means that we get rid of the surds on the bottom of the fraction, also known as the denominator here. So a over root b, if we were to rationalise the surds, we'd have to times the top and bottom by root b, so that we can get rid of this root b surd here. A root times by itself makes the number inside itself, which is b. So we have essentially rationalized. So for instance, let's say we have 4 over root 7. If we want to rationalize this surd, we essentially we have to times root 7 by itself. So root 7 times by root 7 is 7, and then 4 times root 7 is 4 root 7. So that is it rationalized. Sometimes maybe we may get it in this sort of format here. So our denominator is maybe a plus root b, or our denominator may be a minus root b. However, when we want to rationalize, we rationalize by the opposite sign. So for this instance at the top here, we have to times a plus root b by a minus root b, because if we expand out those two brackets, we get a squared minus b, essentially. So let's do an example. So let's say we have 3 over 2 plus root 5. If we want to rationalize this surds, we have to essentially times by 2 minus root 5 for the top and bottom. Okay, so if we do 2 plus root 5 and we expand that one out, and 2 minus root 5. If we use our FOIL methods, so first we would do 2 times 2, which is 4. Outside is 2 times minus root 5, so minus 2 root 5. Inside, so root 5 times by 2, which is positive 2 root 5. And then last, root 5 times by negative root 5, which is 5. The minus 2 root 5 and the positive 2 root 5 will essentially cancel out each other. So these two cancel out. So essentially all we are doing is 4 minus 5, which is minus 1. So minus 1 at the bottom, and then 3 times by 2 minus root 5, which we get as 6 minus 3 root 5 over minus 1, which is the same thing as saying minus 6 plus 3 root 5. Okay, now we've got some exam questions to go over, so let's do them. So this one here, we have to express this in the form of a plus b root b. So whenever you have a question that is in this sort of format here, so a plus b root 2 from this fraction to the left here, that means we are going to be doing some rationalizing. So 1 plus root 8 over 1 minus root 2. So if we look at this root 8 in particular, we can essentially simplify this root 8, because root 8 is the same thing as saying root 4 times by root 2, right? Square root of 4 is 2, so root 8 is the same thing as saying 2 root 2. So let's change that into that. So 1 plus 2 root 2 over 1 minus root 2. And when we rationalize surds, so when we have it in this format, 1 minus root 2, we have to times the top and bottom by 1 plus root 2. 1 plus root 2. Okay, so using our methods that we use, so that means that we get a squared, so 1 squared minus b, so 1 minus 2. Essentially, if we expand the brackets here, I've essentially just done a shortcut method to it, because whenever you times it by the opposite sign, you always get the a squared minus b, where our a is 1 and our b is 2 in this instance. And then if we do the top one, so we're going to have to expand those two brackets here. So 1 plus root 2. Again, we can use our FOIL method. So first, 1 times 1, which is 1. Outside, 1 times root 2, which is root 2. Inside, so 2 root 2 times by 1, which is 2 root 2. And last, 2 root 2 times by root 2. So root 2 times by root 2 is, so think about it as 2 times by root 2 times by root 2. Root 2 times by root 2 is 2, so we're going to do 2 times 2, which is 4. And then 1 minus 2 is minus 1. Okay, so let's simplify this. So 1 plus 4 is 5. Root 2 add 2 root 2 is 3 root 2. And it's going to be over minus 1. When we divide by minus 1, the signs will change. So this will be minus 5 minus 3 root 2. And that is it. Okay, now we have this one. Simplify fully root 45 minus root 32 plus root 5. So whenever we want to simplify surds, it is very important for us to remember our square numbers. So let's go from 1 to 10. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Okay. And then you have 121, which is 11 squared, and 144, which is 12 squared. Okay. So when we want to simplify a surd, so root 45, we look at our square numbers and see, okay, is there any square number here that we can divide divisible by 45? 45 is in the 9 times table, so we can do square root of 9 times by square root of 5, because 9 times 5 is 45. Square root of 9 is 3, so essentially root 45 will turn into 3 root 5. Same thing for root 32. If we look, 4, yep, matches because 32 is in the 4 times tables. So root 4 times by root 8. Oh, actually, we could potentially do root 16. Because 16 is in, 32 is in the 16 times tables. So, yep, let's do root 16. So root 16 times by root 2 makes root 32. Square root of 16 is 4, so it'll be 4 root 2. And root 5 just stays as it is because you can't simplify that. So now we've got 3 root 5 minus 4 root 2 plus root 5. So we can only simplify the root 5 and the 3 root 5. So if we do 3 root 5 add 5 root 5, we get 4 root 5. So this will simplify to 4 root 5 minus 4 root 2. And that is it. Okay, now I've got another question, so another simplify fully. So let's do it. So root 98, again, we can write, let's write out our square numbers again. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, off the bat, let's look at root 98. 49, yep. 98 is in the 49 times tables. So square root of 98 is the same thing as saying square root of 49 times by square root of 2. Square root of 49 is 7, so 7 root 2. Square root of 50, yeah. 50 is in the 25 times tables, so it's the same thing as saying square root of 25 times by square root of 2, which is 5 root 2. So now we're essentially doing 7 root 2 subtract 5 root 2, which we get as 2 root 2. Beautiful.